Vale. Bueno, buenas tardes. Primero quería daros las gracias a todos por venir. Mi nombre es Chema Casao, soy de Stratio y me vais a permitir una pequeña introducción porque quería dar las gracias a Paolo de Confluent y explicaros un poco. Confluent hoy van a hablar Paolo de Confluent y Óscar de Stratio. Y bueno, pues hemos llegado a un acuerdo de colaboración para, pues ya sabéis, los que nos conocéis, que teníamos el Meetup de Kafka, que sabéis que es una de las tecnologías que usamos en Stratio, tanto para el producto como para los proyectos, y lo teníamos un poco abandonadito. Entonces la idea ahora, gracias a Paolo y a Confluent, es activar la comunidad y tenemos la suerte hoy de que va a venir pues, a hacer hoy una introducción de Kafka y Óscar nos va a contar un caso de uso muy interesante, pero ya en septiembre va a venir otro evento y la idea es que bueno, pues que hagamos esa labor de difusión de Kafka, de la tecnología y como siempre con el espíritu de estos eventos, que sea un evento de comunidad y de aprendizaje para todos. Así que, Paolo, thank you very much for coming. So, please, welcome to Madrid.
Thank you. Hello, everybody. Thank you for coming. Okay. Let's see if this thing works. First of all, let's try to know each other a little bit. How many of you are a developer? How many of you are a system administrator? How many of you are something else? All right. For developers, how many Java? Scala? Python? C, C#? Rust? Good. Oh, we don't have a client for Rust. Okay, let's start. Mine is a very brief introduction on Kafka, but I want to give you a feeling of the project Kafka from the inside and the company around it. Oh, before we start, next time, beer before, then we do the talks, and then more beer at the end, yeah? And I want to tell you a little bit of a project I did last year. I joined Confluent at the end of 2016. And this was a project that we did with a government. I will tell you the government. But forget about technology. And if you think about how we handle data these days, I will do a claim that is strange. Database lose data, or they lose the history. Yeah. If you look at a database of customer, you look at the person, the email address, the phone number, you just see the current value. You don't see all the previous value. Database don't keep the history. And if we look about data, you can think about that everything is a sort of like an event. Is something has happened at a certain point in time. And we record it as we sold something, we received an invoice, we made a trade, or we had an experience in interaction with a website or an application. If I add something in a shopping cart, I don't check out, it's still an event. And sometimes these events are valuable. And imagine a government where you don't need to read any of the documentation of how the government works. You don't need to know the rules. You just tell them your event. I'm having a child. Somebody in my family died. I broke my leg, I cannot go to work. Am I entitled to some money? I don't need to read it. I just tell my government the event. And Norway, the Norwegian Work and Welfare Administration, is just doing this in Oslo. They have this vision that is very powerful, and they are delivering right now, where life is a stream of event. So they tell their citizen, don't read the rules, just tell us what's going on, and we will act for you. So an event of a person becomes an event in Kafka. And all the departments, all the governments will read it and act upon it if they need to do something. And in Norway, of course, they don't have many citizens, only 5.2 million. So the Kafka cluster is very, very small. The retention is forever. How many life events, life-changing events, or that you need to communicate to your government you may have. And sometimes certain benefits, certain things you need to know also the grandmother, grandfathers, and the parents. So the retention of these events are forever. So basically, I will be dead, and there will be still events for Norway citizens in the Kafka cluster. There are other validation and data points that I wanted to bring to you and point you at. For example, recently, the Gartner published a report with the top 10 strategic technology trends for 2018. And they claim, they say that event-driven model is one of these top 10 trends. This is exactly how the government in Norway is thinking and is doing. Where Kafka comes from? Why Kafka was created? What was the problem that the Kafka creators tried to solve? And Kafka comes from LinkedIn. And Jay Krebs, that is the co-creator of Kafka with his team when he was working at LinkedIn, and the co-founder of Confluent, was faced with a very messy situation. This is a simplification. I'm Italian, so I call it spaghetti data integration, or point-to-point data integration. And if you need to count the number of lines, the number of spaghetti grows quadratically with the number of systems you want to integrate. And when you want to add a new source of data or a new destination of your data, you need to pay a linear cost. If I want to talk with n system, I need to write n integrations. And this is simply not scalable. It's slowing down organizations. I worked with another customer last year. This is Nordea. I can mention the customer. And we work with them with the part of the bank that does capital market. They are the only part in the bank I found that are able to draw a picture like this about their system. And it's composed by thousands of lines. The other part of Nordea, the overall of Nordea, cannot even draw a picture to understand how complex they are. So now imagine if we could change from an architectural perspective this system and put something in the middle that we call Apache Kafka between your sources of data and your destinations of data. Now we reduce the number of spaghetti to a linear system, is equivalent to the number of sources and destinations. And if I want to add a new source or a new destination, I don't need to pay a cost that is linear with the number of systems. I just pay a fixed cost, one. I just need to talk with the bus. I just need to be able to read from the bus. Of course, if I build a business on this, if I build an architecture that looks like this for a large organization, it needs to be fault-tolerant, resilient, scalable, always up and running, secure, and all these characteristics. And LinkedIn nowadays works like this. Everything, when you add a new contact to your network, this is an event in Kafka, and it will trigger all sorts of things behind the scene, all in real time. Probably these numbers are old, but this is the amount of data that they store in Kafka. This is the number of messages, 1.2 trillion per day, thousands of data streams, and they feed this data into their data warehouse, their big data, data lakes, and so on. I mentioned already Jay Krebs, co-creator of Kafka, when he was at LinkedIn, a co-founder of Confluent. He wrote a small book called I Heart Logs, I Love Logs. And he also wrote a very interesting small article published on the O'Reilly website. I put here the link. You will see that in the slides I put the link so you can go and read carefully about it. And these are the lessons learned around trying to deploy Kafka scale and trying to do well, what some people call online machine learning. When I receive an event, I need to do two things. One is use this event for my user. Is this transactions a fraud or not? Is this call a regular call or a fraud? Should I reject this? This person, what is the banner I need to show it to him right now? This kind of things is putting a machine learning model in production, but is also there is also the possibility to use this event to update a model in real time. So as events come in, I score, I use the model in production, and I also use this event to online, in real time, update the model. It's not easy, but it's doable. And in this small article, Jay explained what kind of challenges you need to overcome in order to solve this problem. Kafka is not used only on Silicon Valley companies. This is, to the best of our knowledge, an estimate of the penetration of Apache Kafka with the Fortune 500 companies, the 500 largest company in the world. And this, you can see that the more data-driven a business is, the more data-driven a company is, the more likely is that they are going down the route of real-time streams of data and this kind of idea of events in order to become agile, in order to become fast at interacting with their customers. Think about, this is another Silicon Valley company, Uber, for example. When you book a taxi, when you see the car approaching, are all events in Kafka. We do not have only Silicon Valley. This is a slide I wanted to bring you here, just to mention yet another customer, another large organization, and very traditional, a large bank in Canada using Kafka and working with Confluent. And look at the adjective that they use. It's like once they started to do a project, when they deployed the first project and they understood the technology, the adoption was massive and organic. And this is also really, really important. Kafka is not easy from, not always easy from an operational perspective. You need to spend a little bit of time to it. But from a developer perspective, sending a message to Kafka, one line of code. Receiving a message from Kafka, one line of code. Doing a little bit of logic with Kafka Streams, 2-3 lines of code. And this is something that the developer can learn very, very quickly. And the clients for Kafka or the client for Kafka Streams are very small jars with no dependency. And this is also really important when you develop microservices, you want something small. I'm an ex-researcher, and if I look back and if I look at and I think what's driving the adoption of Kafka, what are the industry trends behind Kafka? And I see three trends. First of all, I come from an Hadoop vendor, so I really know well what batch means. And I saw and I see every day a trend of a large organization moving away from batch system and going into real-time stream processing. Some people call it big data. Some people call it fast data stream processing. Think about a bank. Once you give me an app on my phone and I can do payment, I can do all the operations as I walk into a branch, the daily transaction doesn't make really, really sense. At night, you cannot shut down and do the batch jobs. The other big trend that I see is Internet of Things. If you think about sensors that are sending data to a backend system into a data center, these events are all structured, timestamp, a metric, and a value. The temperature in this room is this. The temperature in this room is this, every 5 seconds. And Kafka has been designed to receive events, to receive a series of events and just append them. Yeah, Kafka is perfect for this. Do you have 10 million devices sending you data? No problem. Probably 4 or 5 brokers you will need, but it's doable. And the other last trend I see is microservices. And if I need to summarize what's the big difference? Because we have been seeing service architecture for 10 years or more. The big difference here is that services are exchanging asynchronous messages. I can send a message or I can send data to a service even when the service is not up and running, because this data will be published to Kafka. And if that service is down for maintenance, if that service at a certain point is low and cannot pick it up, it's fine. It will be buffered in Kafka and they can read it from Kafka. So I think this decoupling of services is really super important. You don't want to build a service infrastructure where each service depends on many others, and then when you have a problem, you have a cascading effect. So Kafka is not just about messaging. It has two different characteristics that the messaging systems in the past didn't have. Of course, it's a pub subsystem, so you send a message, it is kept into Kafka, and then somebody could come and take it. But it's different from a queue system. In a queue, when you consume a message, the message will be deleted, disappear. In Kafka, the message will stay. So how long? 7 days, 7 years, forever? You decide. Each topic, each queue, if you want to use the term queue, each topic can have a different retention, and it's configurable. And where do you store the messages? It's on disk. So a topic, it's a folder on disk. A topic is divided in multiple partitions. These are subdirectory into that folder. Each partition is divided in segment, 1 gigabyte each is configurable. And these are files in those folders. So you can have a look at your disk, and that is where the data is stored. And then we saw with people using Kafka, you have this flow of data moving from a source to a destination. You see it moving, and you would like to do a little bit of processing. So a lot of people were using stream processing engines to take data from Kafka into the stream processing engine, doing something, and back into Kafka with the results. So we wrote a stream processing engine inside Kafka, and it's called Kafka Streams. So to summarize, Kafka is not just a pub subsystem. You can store data as long as you want, even petabyte of data if you want, and you can do stream processing. This is me with a Linux background trying to explain to people with Unix background the kind of Kafka APIs. Yeah, I'm taking the content of a file, I'm filtering out and keeping only the lines that contain Apache, and then I'm doing a little bit of transformation and processing, putting everything capital Ks, and then storing the output into another file. In Kafka, part of the Apache Kafka project, you have set a set of APIs to send messages from one producer to a consumer, exactly like the pipe in Unix to send a message from one process to another. We have a set of APIs and a set of connectors to do the input-output. For us, the input could be Oracle database, could be a mainframe, could be an SAP system, could be a file, the destination, Mongo, Cassandra, HBase. There are hundreds of connectors. So these are the input and output. And then, of course, once you have the data in your hand, you would like to do some sort of business logic to process it. This is another way, another metaphor to see the APIs for those that are more familiar with databases or ETL systems. The Connect APIs are doing the extract and loading, and the Transform APIs can be done with the Stream APIs. Let me tell you 2 words of the Connect APIs, because how many of you are using Kafka? How many of you are using Kafka in production? Kafka Connect? So, okay. The fraction of people using Kafka and Kafka Connect is still not well known, and Kafka Streams even less. So let me tell you 2 words on Kafka Connect. It's part of Apache Kafka, as I said. Think about like a framework to make life easy for people that want to extract data from a source and load data into a destination. So we allow you to write connectors, and these connectors will run distributed on a set of machines called Kafka Connect cluster. And you decide 2 machines or 20 machines. If a machine goes down when you are moving data, nothing happens. The flow will continue. Behind the scene, at the end of the day, a connector is still using the Kafka APIs, Kafka producer and consumer APIs. The consumer is still a consumer group. All the benefits that you have in Kafka will be leveraged by the connectors. But there are other benefits, for example. There is a layer of REST APIs that you can use to start up a new connector, see what are the connectors running, and automate the operations. There are easy APIs that you don't need to deal with many things. And we also integrated with, when you use Apache Avro, with a schema registry, and the connectors can leverage this. It's automatically fault tolerance, and I don't need to think about that. And the configuration is a simple JSON file. Yeah, so everything can be automated with Ansible scripts or something like that. You need to know Java. You need to be a Java developer if you want to write the connectors. You need to learn a little bit the APIs. Takes a few days, but once you have done one, it will take you 1 day, no more, to write a connector. It's like writing a small plugin for a new framework. How many of you have used Kafka Streams? Okay, see, very few. I used, in the past, I used Storm, Flink, Spark Streaming, and other systems that were doing stream processing. If I look at Kafka Streams, I will say that the computational power, the operators, are equivalent to existing open source stream processing engines. There is, if you want, there is one thing you cannot do with Kafka Streams that efficiently, let's put it, you cannot do it efficiently, that is sorting data. Because for us, we have only streams of infinite amount of data. What does it mean, sorting? Yeah. Other than that, is equivalent to the other system, and I invite you to make to do a comparison. Go through the documentations and do a side-by-side comparison with your favorite stream processing engine. I'm doing this operation. Do I have this? How do I do? From a client perspective, from a developer perspective, Kafka Streams is a single jar with no dependency. It's a small library. How do I run it? You can put it in a Word file and deploy on a servlet container, or you can use Docker and Kubernetes. Up to you. It's a Java application. How do I use Kafka Streams? I just add this library into my class path. That's it. Nothing else, nothing more. And it's a small jar with no dependency. In the past, I had problems when I was using a stream processing engine. It was coming with 100 gigabytes of dependencies, and often these dependencies were not the version of the library that I wanted to use. And you end up in the jar hell problem that you have multiple versions of the same library, and you need to do shading and waste a lot of time to get out of that. There are another beautiful aspect of Kafka Streams is at runtime, you can grow the number of instances that are running your applications, and it will grow you have elasticity. If a machine goes down, nothing happens. The flow will continue. Why? Behind the scene, I still have consumer groups. Each consumer in a consumer group will consume a partition. And if that consumer dies, that partition is given to another consumer. At Confluent, on top of Kafka Streams, we built what we call KSQL. This is about streaming SQL. And basically, and I make it very short, but we take a SQL query and we write the Kafka Streams code for you. And the algebra of SQL is will be very familiar with you. So you have joins, aggregate function, windowing functions. You can do projection, select, and so on. What you cannot do is group by. You cannot do sorting. Same reason as before. And here, for example, you see we create a stream called VIP actions. Is a selector. We take user ID, page, and action from 2 input streams. click streams, and users, and we join by user ID and filter out the user, only the user that have a level platinum. Okay, there is no table behind here. It's just done in real time. This query, you submit it, and it's a streaming query. It will run forever until you kill it. This is really, really powerful. I put a video of 5 minutes to convince you here, but we cannot show it now. And when I show that video, people don't believe it. And there are no tables. It's just input Kafka topics behind the scene. This is a picture to give you for the architects or people that work as a system administrator, just to give you an idea, an intuition of, from a logical perspective, Kafka Brokers and Zookeeper are my core cluster, at the core of my cluster, and everything around it can be managed by different people. So if you want to use Kafka Connect, you see I put it between the sources and the systems. You could have multiple of these clusters. We develop a REST proxy, schema registry. The stream processing application, different team. They don't need to be the same team that is managing the Kafka Brokers. KSQL server, different teams. Each team around Kafka can use different versions. And this is for people that think about bare metal. This is the layout of the same number of nodes in 3 racks. And this I can kill a rack and it's still up and running and processing data, or there is no single point of failure in this diagram, this system. I come from an Hadoop vendor, and I see 2 sides of the coin. For me, batch and streaming needs to live together. There are certain workloads that make sense to do in batch, where you want throughput rather than latency. There are certain workloads where you want very, very low latency, and then a true streaming processing engine like Kafka Streams is what you want. And here I try to put a diagram to show you exactly this. And of course, you need to have these 2 systems talking to each other. You need to be able to send data from Kafka into Hadoop and so on. And we can do that. I mentioned a trend, and you will do a talk on microservices, so I'm not going to take a lot of time here, but I say Kafka is a very, very good fit for microservices architecture. Often you have hundreds of small services, and you want them to talk in an asynchronous way, and Kafka is great for that. Plus, you can also do stream processing to do complex logic, to build aggregate function, filter, and provide reports in real time. This is my colleague Ben, and he wrote a very nice book on designing event-driven systems 1 year before the Gartner was saying it's important. It's important when you look at an open source project to understand who is behind. How am I doing with the time? I think I'm on time. Okay. It's important to understand who are the people behind it, who is driving the project forward, how they do, how they work, how they interact with the community, and try to see where they work, why they are there. So here's my way to capture the Apache Kafka PMC member and the committers. The Apache Software Foundation works in this way for every project. There is a number of committers. These are the people that are allowed to check in, check out code and make changes on the Apache Software Foundation servers. And then there is a subset of PMC member that can bring in new committers and can take important decisions on the project. So here you can find up in the top left corner is June, is our chief architect or main engineers. And then Nea, she is our CTO. And then number 4 is Jay Krebs, that is our CEO. And Nea, June, and Jay were all at LinkedIn and were part of the core team that created something to solve the LinkedIn problem, and then they decided to call it Kafka, and then they decided to make it open source and donate it to the Apache Software Foundation. I was looking at some data points to give you, to inspire you to learn more about Kafka and invest on your personal skills. Maybe learn Kafka Streams or learn Kafka Connect. And Udemy is a community about learning. You probably know it. You probably have seen it. And they did a survey across 20 million users and customers that they have. And they compiled a list of the 10 hot skills for this year, 2018. Number 1 is Kafka. Yeah, go and check it out. At Confluent, we are very open as an organization, very transparent. Not only we contribute massively to the open source project, most of the things we do are open source. Not all Apache Software Foundation project for various reasons, but they are open source. You can find it on GitHub. All our documentation is online. And when we write books, and I put some books here, we also share it for free. So you can download these books. And I would really recommend to read the one from Jay, I Love Logs. If you are developing microservices, designing event-driven system, it's a great, great, great book. And then, of course, for the Bible of Kafka is first edition is Kafka, the Definite Guide, written by Nea and Gwen, 2 of my colleagues, and Todd that is working on LinkedIn. On open source project, this is what my simple way to say, it's not just about the project. How many of you are using Linux? Do you build up your distribution? Maybe when it's something you can do at the university, but not in the real life. And same, how many are using Hadoop? Okay, a few. Are you building up your Hadoop distribution by yourself, or you're taking one from the vendors? And this is it. So Kafka is at the very beginning. Kafka is simpler than other systems. So in theory, right now, like for Hadoop at the beginning, like for Linux at the beginning, you could download all the source code and build it from yourself and do everything by hand. But it's not what we should be doing in our daily job. We should be focusing on the need of our company. What we really try to achieve. These are just tools. Yeah. So Kafka, for us, is Confluent is what Kafka is what we do. We build the distributions of Kafka and ecosystem project and component around it. I put a slide to show you. Most of the things, as I said, we do are open source. There are certain things that we keep away and we want to use it to exchange for dollars. And we build RPM packages for Red Hat, CentOS, and all the other derived Linux distribution. That packages. We also build Docker images, and we publish those on the Docker Hub. And we share also the source code that we use to build the Docker images. So if you need to make a change, customize it a little bit, you can check out our source code, add your own changes, and build the Docker images for you. And we also run perfectly well off Mesos. And of course, you can download all the source code and do it by yourself. And this is a small demo. You can check it out. I was really, when I started, I was doing demos all the times, and I'm very super lazy. So I said to my colleagues, we should have documentation on how to run the demo, but not internally. Let's share it with everybody. We should publish our demo code on GitHub, and we should also have videos of one good guy, good speaker, not me, recorded himself doing the demo. We have all of this now, and so go and check it out. This is taking live changes from Wikipedia that they publish on the IRC channel. We develop a small connector to take those changes, load it into Kafka. We use KSQL to transform this data, and we load it into Elastic. And with Kibana, we give you a dashboard that shows you right now who are the 10 most prolific Wikipedia author right now, what they are doing. All of this is with monitoring. All of this is with security. It's a demo. It's a demo. Promise you won't use it in production. It's just a demo. But it's with Docker. So you can install everything on a laptop very easily. We put everything, all our code, and all our packages online. You can download it. And that's it. That's all for me. Okay?
Hello, good evening, hello. Thanks for coming. Let me introduce myself. I'm Oscar Gomez. I work in Stratio as software architect and developer. And there is my contact info, so feel free. And this is more or less the agenda for today. We're gonna start talking about some basic of event driver architecture. Then we try to explain a use case. I have to say that it's not in all the detail I would like, but for some privacy policies of our client, I can show you all the details. Then I want to show you the architecture solution for this use case and how we understand or try to understand the business of our client and develop the best architecture for this problem. And then we test it in production, and with all the knowledge that we can get from this test, how we try to improve this architecture. Okay, for event drivers architecture, the best way I found to explain is in words of Monty Fowler, something like that. Is we can talk about event driver architecture when we understand our enterprise application like a system that reacts on events for outside the world. And for this event driver architecture, we have several patterns, and depending on the use of this event, we have perhaps the simple one, that is the event notification, when the system only sent an event notification when something changed, and really don't care nothing about the response. Then we can evolve a little and can talk about the event created transfers, event created state transfer. That is when our system not only notify a change. In this event message, we're gonna send all the details that the recipient system needs to work. So these systems that are receiving events don't have to tell nothing or communicate for nothing with the source system. With this information, it can work alone. My favorite is the event sorting. Thank you. The event sorting that the basic idea is not to share the state, not to share a notification. Notify the change per se of your system. Because perhaps if you are managing a stock of a store, and you are selling pens. If you sell 5 pens, you only have to send to the event bus, hey, are 5 less pens in our stock. So with this approach, the event store becomes the principal source of truth of our system. And we can reconstruct the state of it only replaying that event source that can go with a Kafka cluster very, very easy. And this is a pattern that is not a event sorter pattern, but is something that combines very well with these patterns because it's the command and query segregation responsibility. That is nothing more that separate our writing and reading data models in different models. When we go to implement event-driven architecture, maybe always we have a message broker like Kafka that is nothing more than message system through the service communicate, but you can do in brokerless mode that when the service communicate directly. Well, this is the benefits of that, but I think Paolo talked better than me than that. So it's loss coupling, message buffering, explicit event interprocess. And this is some of the drawbacks, but I think the only we can pay attention is the operational complexity, because with the new technologies, the bottlenecks are not really a problem. And that's the basic idea of what is event-driven architecture. I'm going to present you what is the real case we implement. We have for this appointment creation system. Okay, it's when you have to go, for example, to mechanic, to your car to the mechanic, you have to do appointment in the center you're gonna go. This is the requirement. It's little blah blah blah. It's only the user can consult calendars and be able to create appointments. And the interesting thing at this part is that we have one requirement. What was if we find that appointment has several probability of miss, we can overload the capacity of this whole of this availability, and we were gonna see how to do it. We got admin users that can query all the appointments, all the existing appointments, and can create an appointment in the name of a user or a client. And we have BI users that, with all this information of the appointments, can do some analytical use of this, some metrics, showing it through dashboards, all these things. And also, we have a requirement to have a bunch of data scientists that can do advanced analytical with this data. This is our performance required. That is not so easy. That we can have response time more for 250 milliseconds. Our system has to support 10,000 online users doing operations in windows of 2 minutes. And the replication data between the operational part and the analytic part, delay has to be less than minutes. For this problem that don't seem easy, this is our big picture proposal of the architecture. That and what you see is we have a microservice layer with the domain services that has his own persistent. We want a Kafka broker to all the message change, so with the message to manage the message, and we have always to communicate with the informational part. We do this with a tool developed in Stratio that is Sparta, that is built on top of Spark streaming to do some aggregation, persists in a model and HDFS for historic data. And we have some tools to do dashboards and some advanced analytica. This is our approach, our first approach, our microservice architecture. The first thing I want to say is that this is our first approach. This is the first contact with the client. We don't know so much about his business. So in a domain-driven approach, we only identify the big domains that are those three that you see there. And we want to spend so much time and do the work of a split it directly, because you're gonna fail for sure. You're gonna can go to a simple way, and when the use comes, it is gonna give you the experience to do this split well. What you have to do really is be really conscious with implementation and decouple it as much as possible. All you can see here is, for example, the appointment domain is a service, a big service with two main functionalities that is implemented totally decoupled. It's no dependencies between it, and between this, when it needs to communicate, is an event sending or event publishing, not directly, no HTTP calls, no sharing some POYOs or some model objects, nothing like that. This is perhaps the more detailed for the appointment use case. We have to create an appointment. For create an appointment, we have a PostgreSDB in our first approach with a strong constraint. If the insert is possible, okay, you can take your appointment. It's the truth. You have an appointment. When it happens, we populate an appointment event. This appointment event is an internal event. It's like, for example, front-end application do all the time. It's an internal event that is receiving, but this functionality over there, that is, we call it absentees, that we're gonna talk with the appointment propensity model. That is an AI model that bring us the result of a AI training model that give the absentees ratio, the probability of this appointment will miss. With this information, we propagate other event that is the absentees event in our request response approach, and the appointment will update this enriched data on the database. At the same time, we populate an event. This is the event that will travel to all the systems. That is put in an Apache Kafka and is receiving by the calendar and update the calendar model. If you see there, is our first warning, caution, heavy traffic. We will explain it a little more in future. And this is our calendar model. We got the other two domains, the agenda domain, that is nothing more than the rules to create a calendar, to create a viability calendar. This something like this employee attends appointments on this center from Monday to Friday, from 8 to 12. With this kind of we go an initial node in a main cat solution, and then we only do the queries to the calendar. For the created event query, we use the same model of the visit creation, that a visitor is the other warning we have. We will explain it in more detail in next slides. And this is more or less the architecture for the KPIs, the metric part. These domains and these events we talked before are traveling about through Kafka cluster. We have another persistence for events just for security. We never use, but for security. Go to this tool, this workflow tool built on top of Spark, and process the data in different way to build some KPIs that can be visualized in a dashboard tool, like this Discovery, that is other Stratio tool. And this is more or less the first approach of our architecture. And with this, we have this performance test scenario. That is, well, we are deployed in Azure Cloud, and we have a prepared for the appointments models to do some realistic to the realistic fashion to the test. There are more of 84,000 of agendas registers in our cache. That is correspond of a year of real production data of our client. And we have all the production master data loaded in the system. And we're gonna test with this distribution. 37% of calendar set, 16 appointment insert, 15% of appointment rescheduled or canceled, and 30% of created appointment. That is the distribution that the numbers of the client can say. This is the real numbers of the existing system use. This is the resource configuration. We have the calendar microservice with 4 cores and 4 gigas, with an autoscaler config from 2 to 5 stamps. The appointment with just 1 core and just giga and the same instance. And the master, that is other service that only give the, for example, the user data or the center data with these numbers. And this is the number that I think that is that good number. We reached the goal. That is for 2-hour performance with 88 transactions per minute with more than 10,000 users. We have a media of 20 milliseconds for calendar search, or since these are the numbers. Very really good number. This is the requirement, but we do so well that we double the requirement, and the numbers are still good and still in the requirement. We are still doing the goal. But this architecture, as you see, is not perfect. It's the first approach, and we are noticed some in those steps. We saw some gaps or some possible points of fracture. That was in the create that warnings that you see in the previous slide. That was the appointment cert, the calendar service responsibility has too many, and the catch system. For the appointment cert, we really are using the same model. So when the load is high, the performance slow down. So perhaps it's not the best solution. And the calendar, the same thing. Have the responsibility of receive Kafka events and process it with the calculation of overbooking and update the catch system. And at the same time are attending requests for calendar availabilities. Too much responsibility. The numbers are good, but I think that can be even best. So on the main capture, we have good number with the solution, but this is not a really distributable, not a scaling solution, and they don't have its own persist. We have to persist ourselves all the info to crash recoveries or something like that without. If you don't have this, you have to replay all these events and get to the state you have before the crash. So if you have a persistent system, it's better. And with this number, we have this more sophisticated, I think, architecture. When you have Kafka as real data backbone, with a segregation within command and query model for the appointment domain. And for this query model, we are using, or we are implementing now, a Kafka Stream consumer for all these events to load that query model. And the same thing for the calendar. We change the cache solution for Apache Ignite. That was a really scalable and distributed cache solution. And for the update of these calendars, we do a stream consumer from Kafka that is a functionality of Ignite itself. And we have the query calendar, the query directly to Apache Ignite that have a SQL way to do that Memcache don't have. This is more or less, I think that I go so fast, but sorry. And this is all we have for today. If you have any question, it's time. Ahora mismo lo estamos probando. We are trying now, and don't have the same load for the system, but now in the calendar cert we are on the perhaps 20 milliseconds, 25 milliseconds for the same load, so it's a good performance. And for the appointment, we have pretty much the same numbers, but the query is better, and we can, with this stream, we can enrich the data and to facilitate the life of the front people. They don't have to do a lot of requests to get the data. Yep. More questions, more t-shirts. Yep. ¿Perdona? No soy la persona más adecuada para contarte esto porque no soy de sistemas. I'm not the best person to do. Vale. Si lo hubieras dicho desde el principio. No soy la mejor persona para decirte esto porque no soy de sistemas, ¿vale? Pero sé que teníamos un clúster con 3 brokers, ¿vale? Por eso, aquello de la alta disponibilidad y estas cosas. Y realmente no era, o sea, según ellos, no era demasiado grande. Es todo lo que puedo decirte, lo siento. ¿No? Luego me pide la camiseta, está muy lejos. ¿Vale? ¿Sí? Bueno, él iba primero. ¿Sí? ¿Sí? No te oigo nada, lo siento. ¿Sí? Porque necesitamos una transacción fuerte ahí, ¿vale? O sea, lo primero que necesitas es, tu negocio es crear visitas. Entonces necesitas una respuesta así y además, como necesitas una respuesta así de rápida, lo que necesitas realmente es que la propia base de datos pueda resolverte eso. Es decir, tú creas una constraint fuerte para decir, puedes o no puedes crear el appointment, la visita. Si la base de datos te dice que puedes, eso es verdad, la cita está creada. Y luego ya disparas tu evento y haces todo el procesamiento del dato que tienes detrás. Pero, o sea, si lo hicieras en Kafka, te irías de una manera asíncrona, no tendrías esa respuesta rápida. Estaba el primero. Sí, no es una cuestión de confianza en el delivery de Kafka hasta ahora. De hecho, algo que no he contado es que nuestro sistema de recuperación de la base de datos es hacer un replay de los eventos en Kafka. O sea, es nuestro backup, digamos. Es por temas de tiempo de respuesta. O sea, fíjate, teníamos que conseguir que todas las operaciones contestaran en menos de 250 milisegundos. Para dejarlo en un sistema síncrono, a lo mejor es jugártela un poco. No, la verdad es que ya te digo que las pruebas de estrés eran bastante heavy y no hemos tenido ningún problema con esto. Estaba primero él. Dime, Gastón. La verdad es que ahora mismo estamos probando. Bueno, tú lo sabes mejor que nadie. Lo estamos probando y este es el primer caso de uso que yo he visto súper útil de Ignite, pero tal y como está funcionando, de hecho me quiero cargar el Postgre. No, eran todo Spring Boot, ¿vale? Sí, todo Spring Boot. Y bueno, sí que, por ejemplo, para este stream estoy pensando hacerlo en escala porque es más fácil. Porque es más bonito, más que más fácil. Por mí no es más fácil. No, Spring Kafka directamente. No Spring Cloud Stream, sino la librería de Kafka directamente, por temas de versiones. Cloud Stream te obliga a ir con ciertas versiones y nosotros necesitamos un poco más de elasticidad. Me están diciendo que se acaba el tiempo. Ah, ¿no? Bien. Bueno, pues más. Podéis preguntar más. Me he quedado con vuestras caras, luego tenéis camiseta, creo. ¿Sí? Por eso la separación de responsabilidades. Ese fue el problema por el que en este primer acercamiento que hicimos no teníamos claro cómo se iba a comportar, no vimos problema, pero sí que, no llegamos a tener realmente el problema. O sea, las pruebas de estrés todo fue bien, no tuvimos ninguna pérdida, no se cayó, no tuvimos cosas raras, pero sí que vimos que en algún momento podía ser un problema y por eso hicimos hicimos esa separación. Lo intento. Es que se ha ido la pantalla. No, es digamos la misma instancia de Postgres, pero son bases de datos distintas, con esquemas distintos. Sí, eso es otro acercamiento, pero digamos que esto es iterativo. Ahora mismo la infraestructura que tenemos es esta. Si realmente identificamos que la query puede ir más rápido, que tenemos problemas con esa query, es que realmente no son muchas, ni es un modelo muy grande. Entonces, a lo mejor no nos compensa meter otra tecnología más, o sea, manejar otra para algo que realmente no estamos necesitando. Sí, es una muy buena pregunta. Nosotros nos la hemos planteado también. ¿Todo? Muchas gracias por venir.